Hello and welcome back again to Savannah's in Robotics. It's Simba again, and leo nazungumzia kuhusu the drivetrain without the propeller. So naongelea kuhusu drivetrain, so that's why you can see there is a lipo cell here with A, there is an electronic speed controller, and there is a B.L.DC motor. So what am I talking about? These three components, very important when rationed well. These three components, when rationed well, make what you call the drivetrain. I spoke about that earlier. So the drivetrain is important because it allows you to work with certain parameters that you cannot disqualify if you want your component to survive. In robotics, it's very important to understand the figures behind what you're doing, because it's the figures that count very much more than probably what you're using, the type of the manufacturer and the condition your equipment is in. What matters at most is the drivetrain. You need to understand the kind of power you're bringing in, the lipo cell, kind of energy you're bringing in. You need to understand your processing unit. This is the mini computer here now. And then you need to understand the output that you are getting and what kind of unit is giving the output and what amount of output you want it to give. So for instance, you will notice that on the lipo cell on the left, I have not labeled it. Why? Because a 30 amp electronic speed controller, E.S.C, a 30 amp electronic speed controller just uses a certain amount of energy that is coming up from a lipo, or even if it were an 18650 cell, so that it translates that into information to be given to the B.L.DC motor so that it can rotate at certain amounts of rotations per minute. Now you'll notice here that even without the information on the lipo cell, you can know what to deduce here by looking at the electronic speed controller. One, you can see it is written 2 to 4S lipo. I said earlier that 2 to 4S just means 2 to 4 cell lipo. The S stands for cell. Lipo, lithium polymer battery. So when it is 2 to 4S lipo, it just means that this battery here is either a 2S lipo cell or it is a 4S lipo cell. Anything beyond that will burn the processing unit, which is the electronic speed controller. Now, coming this way, you'll realize that there is a B.L.DC motor. Now that B.L.DC motor should not be anywhere beyond 2000 kV. In fact, at best, it should be at least 920 kV. If you want to work very moderately with this, you should use either 920 kV to 1000 kV B.L.DC motor. So that is a brushless DC motor, direct current motor. You should work with one that is less than 1000, because now you're not putting in a lot of power. You'll notice that you're not putting in so much energy from the lipo cell. It's just 2 to 4S. Now anything beyond that will either not rotate the motor or will make the motor redundant in its own way. So what is there to be deduced today? You just need to know how to work with your combination. And when you're working with it, you need to know what you're getting from the lipo cell to the electronic speed controller and what is being given out on the B.L.DC. So this comes in as an energy pack. The lipo cell is an energy pack. Electronic speed controller is a mini computer. And then the B.L.DC motor is the unit that gives the output of all the information that is being churned out through the mini computer here, which is the electronic speed controller. Something else also that you need to remember is that all these units are standardized all over the world. You do not need to buy these compartments from one company. However, it is not as strict as it might seem. You could buy all these three components from different companies. These three components, if very well balanced out mathematically, will just work fine. They must not all come from one company. It must not all be a similar company. Different companies, but if you work with the parameters that have been given, you will still get results. So all you need to know is that the figures that you see on a brushless motor on an electronic speed controller and on a lipo cell must be adhered to for you to get the feedback that you expect. Otherwise, you will either be working with a drivetrain that is unnecessarily too powerful or that is too weak to function the way you want it to, or you'll just burn your component and then your contraption will be dead on arrival. So all you want to realize is that the lipo cell, the electronic speed controller, B.L.DC, are all interrelated as stipulated by the figures that you see in front of them. Yep, welcome back. So to just probably hammer in the detail, as you can see here, this is what it would look like in reality. So this one is a Tattoo battery, Tattoo company battery. This is a Simon K firmware company that has made this, and this has been made by the very popular DJI company. So if you realize all these three, if just well connected, because that is 3S, meaning it falls between the bracket of 2 to 4S, 2 to 4 cells, it's 3 cells. This is 30 amp, meaning it is just right to work with that. 920 kV, which is in the parameters of either a 3S, as it is indicated here, 3S to 4S lipo. So if this was the drivetrain, it would work just perfectly fine. An important aspect to remember. So hiyo ni aspect moja important sana kukumbuka, ndio kuwa able kuwork na hizi vitu vile ziko, create contraption yako bila kuwa troubled kuangalia kama gani itabana nyingine. Si lazima zitoke the same company. Nimesema that comes from Tattoo company. It's known for its lipos. This comes from Simon firmware company, which has lately been, redundant a bit, but still the algorithms here work. Na inatoka kwa the popular DJI company. But if you just follow the parameters of the cell, number of cells, of the amps here, and of the kV here, so that's the most important aspect. When it comes to the power, you're using the required number of cells. When it comes to the electronic speed controller, you're using the required number of amps. And when it comes to the motor, you're using the required number of kV. If you do that, your unit, your contraption will work just well. Asante sana. Remember to subscribe. 7RC Robotics here. Thank you.